All right, sorry about that, it cut off there. Here's my lowest, I'm just identifying the maximum in. And my highest, oddly enough, is 0, right? So here's my high. And so I just want to summarize that my absolute minimum value was at -1, -5. My absolute maximum value was at 0, 0. And there's my solution. Okay, hopefully the last video, we'll turn the page. This one's got some trig, it's a long one. We're going to find our absolute extremum for this function. All right, same steps as before. My derivative, the derivative of 2 sine x is 2 cosine x. The derivative of cosine of 2x would be minus sine, so I'll end up with a positive sine of 2x. But because I have the chain rule with the 2x on the inside, I actually have a 2 out front. And I want to go ahead and determine where this is equal to 0. Kind of like that first one, I actually don't need to worry about undefined values. Cosine of x is defined everywhere, sine of x is defined for everywhere. So when you have a combination of those two that are continuous functions on all real numbers, you'll end up with another continuous function with a domain of all real numbers. So I don't need to worry about where the derivative is undefined. I do need to worry about how to solve this. We can go ahead and on this one, if you did it by hand, you would need to use your double angle formulas, but I'm going to go ahead and show you this one with your graphing calculator instead. So let's go ahead and find our graphers. As always, you want to press the mode button and make sure that in calculus you're in radians. So let's go ahead and clear out whatever was there and type in our function. Plus 2 sine 2x. And I'll look at my graph. Oh, my graph is showing up a bit funny because I was graphing something different before. But actually, this is a perfect time to show you that we really don't need to graph this function over sort of like the standard window. We only need to know what's happening to our function on the interval from 0 to 2 pi. So I meant to hit window, not mode. Let's set our x values to start and end exactly where we need them to. You might want to count by like pi over 2 or something like that, just to make the tick marks a little nicer. And let's zoom out just a bit. I had a funny setting from my previous graph, but -1 to 1. We're really looking for zeros, so I don't need a huge graph. I just want to know what's happening around the axis. And so here are my values. Right? I can go ahead and I can calculate my zeros. Gotta move my bounds around. Let's see where I'm at. I'm trying to find this very first one on the far left. There it is. So I am to the left of where I think the 0 is, and now I'm to the right. I've moved past it, and I'll press enter, and I'll get 1.57. So my critical numbers are at 1.57. Perhaps you notice that that's pi over 2. Goes right through that nice coordinate. And I'll do it again. I'll find the next 0. I'm to the left, I've moved past to the right, and so I got 3.665. My next one, trying to get a little bit closer, should be at 4.712. And the last one, it is possible to do this one by hand. You would just need a double angle formula. But I did want to show you how to use the grapher. The last one is at 5.7, ooh, this is a tough one, 5760. So those are my x values. And then I'll go ahead and I want to test all of those values plus my endpoints. So f of 0 I can get a little sneaky here because knowing about trig, right, f of 0 and f of 2 pi are going to be exactly the same. So it's probably faster just to go ahead and plug them in by hand than it even is on the calculator, because cosines and sines of zeros and 2 pi's are simple to work with, right? The cosine of 0 is 1, so this will be 2. But the sine of 0 is 0, so that'll be 0, and I got a 2. Oh. Sorry about that. I messed up. I plugged into the wrong thing, didn't I? I want to plug into my function. So this would be 2 times the sine of 0 plus 2 times the sine. Or, I keep doing it wrong. 2 times the cosine. Where did my whiteout go? My eyes keep looking at the derivative. Minus the cosine of 0. And so I'm going to get minus 1. Sorry about that. This will be equal to f of 2 pi. The function's the same at 0 and at 2 pi. And then I'll go ahead and I'll plug in the other values. 1.57, 3.